Alrighty, this is Math 110, question that was sent in. I think it was sent in Wednesday. This is 2.1, number 21 in the book, number 5 online. Number 21 in the book, number 5 online. Okay, this is called what you call a piecewise function. Let me get my pen started. A piecewise, determine the largest open interval of the domain, which is the function shown blah, 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 blah. Didn't give the domain. Okay, first of all, I do a series of videos on this. Make sure you visit my videos on YouTube because I talk about domain and range and how to find the domain and the range. We know that the domain is equal to the x values that you can put into the function. We know that the y values are called the range. Okay, so I'll kind of condense the videos down a little bit if you haven't watched them. If I give you a function, f of x is equal to x squared, and I tell you you can only use -2, -1, 0, 1, and 2. I have just told you that the domain is from -2 to 2. You can't use 5. You can't use -100. You can't use -1/2. No, I'm sorry, you can, excuse me. You can use -1/2, but you cannot use -3. You cannot use 5. You can use 1. You can use 1/2. You can use 0.33, but you cannot use anything above 2 or less than -2. Okay, so I have set the domain to -2 to 2. All right, so therefore my range is affected. This is your domain from -2 to 2. Your y is your range. So -2 will spit out 4. -1 will spit out 1. 0 will spit out 0. 1 will spit out 1, and 2 will spit out 4. So now my range is from 4 to 4. Okay, or my range is from 0 to 4. I'm sorry. So let's look at the graph. 1, I'm sorry, -1, -2, +1, +2, 1, 2, 3, 4, -1, -2, -3, -4. -2, 4. -1, 1. 0, 0. And 1, 1. And 2, 2. And I think I do this in the video. I'm not sure. I do so many I can't remember. But there is my domain and range. Domain, you can see it graphically right here. From this point, from -2 to 2. And what is my range? My range, use another color here. My range is from 0 to 4. Your domain is the x values that you can use. Your range is your y values that are outputted. I know that's not a good word, but that's the numbers that you can use for the output. The input is -2, -1, 0, 1, and 2. The output is 0, 1, and 4. Okay? So that's a little of what I do in the videos. And please, do not try to take an online class and not watch videos. Okay? Because I did those videos not for the class, I did it for an online class. Okay? I said, why should I record for the class when I can record for the class in the online class in the future? So that's why I did it, for the online class mainly. So don't do that. Don't try to take an online class and not use the videos. Okay, I have students tried that in the past. They weren't too successful. All right, so let's look at the domain and range of this guy. All right, the domain. Well, we got arrows here, so that means it's going to keep going and going and going. Here, this means going, 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 going. So you know, as far as we read from left to right, the domain is going to be from -infinity, which is this arrowhead over here, negative infinity, and positive infinity is this arrowhead over here. So we know that the left side is going to contain negative infinity and the right side is going to contain positive infinity. But we got some breakups in here. But these values are being used for this function. And then it stops. And then it picks up here. And it's being used here for this function. And then here it picks back up and being used for this function. Now, since this closed dot cancels with this open dot, and since this closed dot cancels with this open dot, then your domain is from negative infinity to positive infinity. So domain is negative infinity to positive infinity. Now, if you don't know about the brackets, go to my videos. They'll explain interval notation. Range. Now, let's look at the y values. Well, again, these arrowheads say that from here up, all of these numbers are being used, and that's positive infinity arrowhead on the y-axis, and this one down here is negative infinity arrowhead, and that one goes with that. So we know that from this point, this way is being used. And we know from this point, this way is being used. But these two are not the same. It looks like this is 1.5 and this is 1. Okay, it looks like they're a little bit different. All right, so the range is going to be from negative infinity. And it looks like, since this is an open circle, we can't include that part right there. So that's at negative 2. It's going to stop at negative 2. It's going to pick up at negative 2 and go to 1 right here, because these right here. But I think this cancels this, so I think it's going to be negative infinity to positive infinity. Okay, why do I say that? Because this arrowhead cancels this out. See what I'm saying? And this arrowhead cancels this arrowhead's going to cancel, so I think it's going to be negative infinity to positive infinity. Now, what about increasing and decreasing? Well, it's real easy to do increasing and decreasing. Okay, first of all, let me talk about one other thing. And I'm going to go to the whiteboard here because I'm going to kind of switch gears on you right quick. All right. There's the domain. There's the range. There's increasing. And then there's decreasing. There's only one aspect up here, or one item up here, that is in terms of the y-axis. And which one is that? Well, if you watch my videos, I go over that. And it is the range. This is the only one. The only. I'll say that 5,000 times and somebody will still mess it up. This is the only one that's in terms of the y values. Okay? The only one that's in terms of the y values. So therefore, this is in terms of x, and these are in terms of x. Okay? So, when you're looking at a graph, this is what you do when you're looking at a graph in terms of increasing and decreasing. Which way do we read? We read from left to right, Hubert. Okay, so you think of, let's think of a plane. Oops, that don't belong to a plane. Let me erase that. Okay, I suck at drawing. So if you want to make fun of my drawing, that's fine, but I suck at it. So you're really not making fun of me if I know that I suck at it. So anyway, there's a plane, jet, whatever you want to call it. And that jet, that really don't look like a jet. There we go. Now it really sucks. But anyway, we take this guy and we put him up here. All right? Now, tell me what this jet is doing right here. He's decreasing, Hubert. Yeah, he's decreasing. And then what is he doing from about right here this way? He's increasing, Hubert. All right? So from this point right here to maybe this point right in here, it's decreasing. So we're going to take our handy-dandy red pen and we're going to say, okay, from here to here, we're decreasing. We're going downhill till we get to that point right there. Okay? And then from that point, use my green marker. From that point right here, we are increasing. Because you said a while ago, you said from here to here, we're decreasing. And then when we get to this point, we start what? Increasing. Is that what you said? Yeah, that's what I said, Hubert. All right. That's called, right here, an inflection point. That's where the direction changes. And that point right there is your turning point. We're going to say, for instructional purposes, that that point is 4. X is equal to 4. All right? So, our increasing values are from 4 to, what is this arrowhead called? Infinity, Hubert. That's right. Or this arrowhead, whatever you want to call it. Both of these arrowheads are called infinity because they keep going. So we're increasing from 4 to infinity. Where are we decreasing? Well, this arrowhead is called negative infinity. And so this arrowhead is called negative infinity because it's going in the same direction. And that's negative infinity to 4 is where the plane is decreasing. And that's how you do increasing and decreasing. Now, if it doesn't go up or down, it's called constant. So now that we're going, and I go over this with the videos, so make sure you watch the videos. Okay, anyway, let me go back to the transparent board and go back to our question. Okay. Oh, hit the wrong button. Okay, maybe the drugs and alcohol wear off sometime today. All right, so here we go, and let's look at our graph, okay? Here's our plane. So our plane is decreasing till we get to this point, and that point is -3. So we're decreasing from negative infinity to -3. All right, then what are we doing? Well, Hubert, let's put our plane. I doubt I can pull that plane down, but let's see, because it'll move everything probably. No? Well, it's going to move some of it. All right, we hit down to here, and then what is the plane doing from here to here? It's not doing anything. It's going along the runway. Right here, it's going along the runway. So it's not doing anything. So it's constant from -3 to +4. So it's constant from -3 to +4. Constant from -3 to +4. And then what does that plane do when we get to, ow, sorry, I hit this table. What does that plane do when we get to here at 4? What does it do? It keeps what? Keeps going down. It keeps decreasing. So we've got decreasing over here, constant, and then we've got decreasing over here. So it's decreasing from 4 to what? Infinity. And I lost my decreasing. I don't know where it went. I must have lost it. Let me rewrite it. So we're decreasing from negative infinity to negative 3, and then we pick up at 4 and go to infinity. And that is the increasing and decreasing. All right? So you got your domain, which is going to be all your x values that are being used, and your y values that are being used. And then you got your increasing and decreasing. And in this case, we didn't have an increasing. Okay? Because everything's going downhill except for the constant. Now, union and intersection. Okay? If something overlaps, you have an intersection. Remember your intersection? The asphalt will overlap. You got asphalt going this way, you got asphalt going this way, it's going to overlap right here. An overlap of numbers means intersection. If you don't have an overlap, then you have a union. So if they put a U between them, and I go over that in the videos also. Watch the videos. I don't know if you're watching them or not. I don't have any way of telling. But if you try to take an online class without some kind of help with the videos, it makes it twice as hard. Okay, so I would highly suggest, if you haven't, go to YouTube, pull up Hubert McClure, and click on the first picture, and you'll see Math 110s in there, and you pick any of them. I teach the same each semester. And also look for this. This one's going to be called Virtual Office Hours Math 110 Summer 2017-30. Okay? Anyway, I hope that helps. And if it didn't, then write me an email telling me that I suck as a teacher and I didn't help you and you're going to fail because of me. No, I'm just kidding. Make sure you keep sending those questions, and I'll keep going over them as long as you keep sending them. If you don't send them, I'm going to assume that you understand it. Okay? So keep sending them, and I'll keep answering them.